This is Trekzone's Talkin' Science.
Well, Trekzone membership is available via the join button under each video on YouTube or via the trek.zone/support. Plus Trekzone's on Twitter, Facebook, Instagram, and your favourite podcast feed. Find us, like, follow, and subscribe. Welcome to Talkin' Science. I am Matt Miller. Now, into the science headlines of the past week. And as you may know, UFOs have been renamed to UAPs, unidentified aerial phenomena. And in early June, NASA announced that it is commissioning an independent study on them. With the aim of moving the scientific understanding of the craft forward, the study team are led by astrophysicist David Spergel, who previously chaired the astrophysics department of Princeton University. Executive board member of the Scientific Coalition for UAP Studies, Robert Powell, told Space.com that NASA should be congratulated for the investigation and that his coalition will urge the space agency to tap into the background knowledge that has already been obtained by other organisations and become familiar with the pitfalls and successes in studying this subject. Now, NASA only intends to collect data at this point, so don't expect any major revelations anytime soon. University of Technology Sydney Masters student Annabelle Jones, who is working with a German company Ein to understand the impacts of microgravity of hormone production as we look ahead to long-duration spaceflight in the near future. As Space Australia writes, future space travel will rely upon an expansive understanding of how the space environment interacts with the human body, and with only 12% of the astronaut population identifying as female, little is really understood about how long-distance space travel will impact hormone production, particularly in women. The research that Jones is conducting involves using a microgravity simulator to recreate the space environment with the hormone samples put through an array of tests to understand if they're affected. Jones is also using 3D printing to replicate tissue architecture, which will also help to simulate the different movements that happen within the cells of the human body. Fascinating stuff. And attempting to save itself from a premature end, a European satellite has narrowly avoided a collision with a random piece of space junk. The satellite, one of many making up the magnetic field monitoring constellation Swarm, has been climbing to a higher altitude after it experienced increased drag due to the changes in the density of the upper layers of Earth's atmosphere following a period of solar activity. Rising 45 kilometres over 10 weeks was put on hold to immediately perform an avoidance manoeuvre on June 30, which once again highlights the risk of space debris in our planet's orbit. This all comes as our star awakens to a period of increased activity, producing more sunspots, flares, and coronal mass ejections, which in turn thicken up our upper atmosphere, producing more drag on satellites. Think of wind resistance on aircraft, requiring these orbit-raising manoeuvres. Now, an Aboriginal language could hold the key to solving some of the most challenging communication problems between humans and artificial intelligence systems. A new paper published by Frontiers in Physics and led by UNSW Canberra's Professor Hussein Abbas explains how the language spoken by the Jingili people in the Northern Territory has characteristics that allow it to be easily translated into AI commands. Professor Abbas said during the Second World War, Aboriginal languages were used for secret communications. Today, we are discovering that the wealth and richness of their languages and culture could hold the secret in human-AI interaction. Working alongside University of Canberra linguistics expert Associate Professor Eleni Petraki and Defence Science and Technology Group's Dr. Robert Hunjet, the team created JSWAP, a language inspired by Jinguli. New research from Western Australia's Curtin University has pinpointed the exact home of the oldest and most famous Martian meteorite for the first time ever, offering critical geological clues about the earliest origins of the red planet. Using a multidisciplinary approach involving a machine learning algorithm, the new research, published in Nature Communications, identified the particular crater on Mars that ejected the so-called Black Beauty meteorite, weighing 320 grams, and paired stones, which were first reported as being found in northern Africa in 2011. The researchers have named the specific Martian crater after the Pilbara city of Cromartha, located more than 1,500 kilometres north of Perth, which is home to one of the oldest terrestrial rocks. The discovery was made thanks to the algorithm developed in-house at Curtin Uni by an interdisciplinary group that included members from the Curtin Institute of Computation and the School of Civil and Mechanical Engineering, as well as the Pawsey Supercomputer Research Centre and the Australian Space Data Analysis Facility, with funding from the Australian Research Council. Scientists have spotted an example of a black hole. The news doesn't stop here at Trekzone. That black hole that should be extremely common, but is quite difficult to find. Discovering these dormant black holes is made challenging because they're not actively feeding on matter like gas, dust, or stellar material stripped from a companion star. With no feeding, there are no X-rays, which scientists typically use to spot black holes. The new discovery could have ramifications for understanding how stars collapse at the end of their lives, according to the researchers. Astrophysicist Tomer Shanar and his colleagues from the University of Amsterdam discovered the stellar mass black hole that contains about 9 times the mass of our Sun, hanging out in the Tarantula Nebula, a star-forming region of the Large Magellan Cloud. The black hole orbits a huge blue star with a mass equivalent to 25 of our suns. The duo make up a binary system that has been named VFTS 243. The 2022 Astronomical Society of Australia annual scientific meeting was held from June 27 to July 1, a couple of weeks ago now, a hybrid event of in-person gathering at multiple hubs across the country and some online participation. Space Australia wrote up some of the highlights of the week-long conference hosted this year by the University of Tasmania. It was hosted in Hobart this year. There were local hubs for meetings in all the major cities around Australia and online participation options for attendees. The jam-packed program contained over 100 talks, around 60 posters and corresponding videos, plenty of research highlights and discussions to keep any scientist busy. Now, the conference, held in winter each year, presents an opportunity for Australian and New Zealand astronomers to come together to share developments and highlights from various fields of astronomy, ranging from stellar physics to cosmology. And what I love about this is that many of the contributions to these meetings are by junior researchers, with over 40% by students and more than 20% of the talks by early career researchers. Very, very cool stuff. I reckon we should head to the conference next year. I'll chat to the travel agent. Well, Dr. Brad's here on the first Tuesday of every month to bring us a roundup of the biggest stories, and I've got your bite-sized wrap on the week. Your bite-sized wrap of the week, the other 3 Tuesdays. I got to work on those words, just like this episode. Thanks for watching Talkin' Science. I'm Matt Miller. I'm going to see you in the comments.
What?